Question 10. Points A, B, C lie on the circumference of a circle with center D. Coordinates of point A, B, C are given. Show that angle ABC is equal to 90 degree. These 3 points A, B, C lie on the circumference of the circle. That this is a circle. Point A, B, C lie on the circumference of the circle. Let this is A point. This point is B. Suppose, and this point is C. Now we have to show that angle ABC is 90. ABC is 90. We have to show that. We have to show that this angle is 90. Now we will find the gradients of AB and BC. If the product of gradient is equal to -1, that the angle must be of 90 degree. So first we will find the gradient of AB. Gradient of AB, M for gradient. Gradient of AB, points are given. The coordinates of A -2, 3, coordinate of B 3, 0, coordinate of C 6, 5. Find the gradient of AB. AB gradient is y2 minus y1 over x2 minus x1. That is gradient of AB becomes -3 over 5. Now we will find the gradient of BC. Gradient of BC will be 5 minus 0 over 6 minus 3. Oh, this is 5 over 3. Now the gradient, the product of gradient of AB and gradient of BC are given. Now we will use this concept. M1 M2 is equal to -1. We will use this concept. Clearly, the gradient of AB, that is -3 over 5 multiplied by 5 over 3, this becomes -1. This product of two gradients, this product of these two gradients is equal to since -1, so the angle at B must be 90 degree. This has been shown. ABC angle is 90 degree. Now state the coordinate of D. D is the uh, center of a circle. Now the using the property of circle that if the angle at the circumference is 90 degree, then AC must be the diameter of the uh, circle. Diameter of the circle. This is the property of, since AB and BC makes an angle 90 degree at the circumference of the circle, so AC must be the diameter of this circle. So the center of circle is this D. So now we will find the coordinate of D. Since the D is the midpoint of A and C, we will take the midpoint of AC. That will be the center of the circle. Midpoint of AC, we will use here midpoint formula. Midpoint of AC, x1 plus x2 over 2, y1 plus y2 over 2. So this becomes the coordinate of D, which is the center of the circle, will be 2, 4. Next, find the equation of the circle. Equation of circle is equation of circle is x minus a whole square plus y minus b whole square is equal to r square. So here a, b are the coordinates of the center of the circle and r is the radius. So a is 2 and b is 4 because the coordinate of center of the circle. So we can write it as x minus 2 whole square plus y minus 4 whole square is equal to r square. Now we will find the radius of the circle. Radius of the circle can be AD or DC. This is the radius of the circle. Coordinate of D we have found. Coordinate of D are 2, 4. Now this is the radius. You can say that AD will be the radius of the circle. We will find by distance formula this AD, so that becomes the radius. So radius will be we will find AD. AD distance will be the AD by distance formula. AD will be 3 minus 2, 3 minus 2 whole square plus 4 minus 0 whole square whole under root. So this becomes AD is equal to 17 under root. This is the radius of the circle. So we can write the equation of the circle finally. X minus 2 whole square plus y minus 4 whole square is equal to r square. R is 17 under root. The square of 17 under root is 17. So this is the equation of the circle. Move to the next part of this question. The point lies on the circumference of the circle such that BE is a diameter. So this will be the circle. BE is the diameter. This is the diameter of the circle BE. Coordinate of B are 3, 0. And this is the center of the circle, that is D. That is 2, 4. We have found already. But this is E. This point is E. So find an equation of the tangent to the circle at E. There is a circle at point E. There is a tangent to the circle at point E. So this is the tangent at E. We have to find the equation of this tangent. So for this angle will be 90 degree. So to find the equation of the tangent, we need the gradient of the tangent and the point through which the tangent passes. Tangent passes through uh, point E. So first we will find the coordinate of E. Let the coordinates of E are A, B. Now we can find the midpoint of BE. The midpoint of BE will be, we use here the midpoint formula. Midpoint of BE A plus 3 over 2, B plus 0 over 2. This is the midpoint. But midpoint is already given, that is 2, 4. Now we will equate the corresponding coordinates. A plus 3 over 2, this is the x coordinate, will be equal to 2. This will be equal to 2, and this y coordinate will be equal to 4. A plus 3 over 2 is equal to 2. From here, A is equal to 1. Similarly, B over 2 is equal to 4. From here, B is equal to 8. So coordinate of E point are E coordinates of E are 1, 8. Now we will find the gradient of tangent. So gradient of tangent will be the negative reciprocal of the gradient of dE. So first we will find the gradient of dE. Gradient of dE will be, points are given, AB are given 1, 8. Gradient of dE is 8 minus 4 over minus 1, that is minus 4. This is the gradient of dE. But what is the gradient of tangent? Negative reciprocal of this. So gradient of tangent will be negative reciprocal of minus 4 will 1 over 4. So equation of tangent, y minus y1 is equal to m x minus x1. Y minus y1, or this is x1 y1, point E, x1 y1. So this becomes y minus 8 is equal to gradient is 1 over 4, x minus x1 is 1. So we will write it in simplest form. By cross multiplying it, it will become y minus 8 into 4 is equal to x minus 1. 4y minus 32 is equal to x minus 1. 4y minus x is equal to 32 minus 1. 4y minus x is equal to 31. This is the equation of the tangent. Now move to the next question of this paper, that is question number 11. The diagram shows the part of the curve with the equation this x power y is equal to x power 1 over 2 plus k square x power negative 1 over 2, where k is a positive constant. K is a positive constant. Find the coordinate of the minimum point of the curve, giving your answer in terms of k. So for minimum point, the value of the gradient will be 0. So first we will find the gradient of this function. Y equation of curve is y is equal to x power 1 over 2 plus k square x power negative 1 over 2 dy over dx will be 1 over 2. The differentiation of first term 1 over 2 x power 1 over 2 minus 1, that is negative 1 over 2 plus k square is a multiple only, just remains the same. Differentiation of x power negative 1 over 2 is minus 1 over 2 x power negative 3 over 2. Now the gradient is 0 because we have to find the coordinate of the minimum point. At minimum point, the value of the gradient will be 0. So we will put it equal to 0. Now this becomes 1 over 2 x power negative 1 over 2 minus k square. We can write it as k square over 2 x power 3 over 2 is equal to 0. Now, on left hand side, we can write it as 1 over 2 x power 1 over 2 is equal to k square over 2 x power 3 over 2. Cancellation of 2 on both sides from the denominator. The remaining is rearranging it, collecting the x values, x terms by cross multiplying process. X power 3 over 2 over x power 1 over 2 is equal to k square. From here, left hand side become x power 3 over 2 minus 1 over 2 is equal to k square. From here, x will be k square. This is the x coordinate in terms of k. Now we will find the y coordinate of the stationary point. We will put this value of x in the equation of the curve. Putting this value of x in the equation of the curve, we will get the value of y. So it becomes y is equal to k square power 1 over 2. We are putting the value of this x in curve equation. K square 1 over 2 power plus k square into k square power negative 1 over 2. After simplifying, we will get cancel out of these power 2 and 1 over 2 in both terms. Y is equal to k plus k, that is y is equal to 2k. So this is the x coordinate, this is the y coordinate of the minimum point. So minimum point, we will write minimum point will be k square 2k. These are the coordinates in terms of k. Now move to the next part of this question. The tangent at the point on the curve where x is equal to tangent at x is equal to 4k square intersect the y-axis at P. So find the y-coordinate of P in terms of k. So first we will find the equation of the tangent. Then we will tangent intersect the y-axis. Then we will put x is equal to 0 because on y-axis x will be 0. So first we will find the equation of the tangent. So we need to find the equation of the tangent. We need gradient and the point. Point is given. Point is given. X coordinate of the point is given. We will find the y coordinate. So first we find the x coordinate is given, that is 4k square. Y coordinate we can find. We can find y coordinate. Putting this value of x in the equation of the curve, y will be 4k square power 1 over 2 plus k square 4k square. We are putting this value of x in the equation of the curve, negative 1 over 2. Simplifying, this becomes 2k plus k square. We can write 4k square as 2k whole square whole power negative 1 over 2. 2 and minus 1 over 2 cancel out, and this becomes y coordinate will be 2k uh, plus k square over 2k cancel. Y will be 2k plus k over 2. This becomes y is equal to 5k over 2. So this is the y coordinate. This is the y coordinate or this is the x coordinate. Now we have to find the equation of the tangent. Now we also need the gradient of the tangent. So we will find the gradient of tangent by differentiating. We have already differentiated it. Differentiating and putting this value of x, gradient is gradient is uh, 1 over, we have already found it in the previous part, 1 over 2 x power 1 over 2 minus k square over 2x power 3 over 2. Now we will put this value of x. X is equal to 4k square. Putting this value of x in the gradient, we get dy over dx 1 over 2 4k square power 1 over 2 minus k square over 2 into 4 k square power is 3 over 2. Or simplifying, we get the value of gradient will be 1 over 4k minus 1 over 16k. So simplifying it, we get dy over dx is equal to 3 over 16k. Now the gradient is also, we have found this is the gradient, these are the points. So equation of tangent will be equation of tangent y minus y1 y minus y1 is this 5k over 2 is equal to gradient is 3 over 16k x minus x1 is given, that is 4k square. So this is the equation of the tangent. But it is given that in a tangent intersects the y-axis. At y-axis, the value of x will be 0. So we have to find the y coordinate of p. So y coordinate, putting this value of x in this equation, we will find, we can find y as y is equal to y minus 5k over 2 is equal to 3 over 16k. X is 0, 0 minus 4 minus, this becomes minus 4k square. After simplifying it, we get the value of y will be 5k over 2 minus 3k over 4 Simplifying it, we get the value of y will be 7k over 4. This is the answer. Now, the next part of this question, the shaded region is bounded by the curve x-axis and the line x is equal to 9 over 4 k square and x is equal to 4 k square. Look at the diagram. This is the shaded region bounded by the x-axis and two vertical line and the curve. We have to find the area of this shaded region in terms of k. Formula for area under the curve will be a is equal to integration of function with respect to x. Now we have y is x power 1 over 2 plus k square x power negative 1 over 2 with respect to x. And limits are also given. We will apply the limits at the end. First we will integrate it. Area will be integrating the right hand side x power. The integration of first term will be adding 1 in the power and we write the same in the denominator x 1 over 2 plus 1, that is 3 over 2 over 3 over 2 plus k square remains as such because it is a multiple x power 1 over 2 over 1 over 2. We simplify it. A will be 2 over 3 x power 3 over 2 plus 2 k square x power 1 over 2. Now the limits are lower limit is it is given. You can see in the figure. Lower limit is 9 over 4 k square. Upper limit is 4 k square. 9 over 4 k square. Upper limit is 4 k square. Now we apply the limits. Upper limit minus lower limit. So this becomes area will be upper limit 4k square. In place of x we will put 4k square. So this becomes 2 over 3 4k square power 3 over 2 plus 2k square 4k square in place of x power 1 over 2. This is the upper limit. Minus lower limit, that is 2 over 3 9 over 4 k square power 3 over 2 plus 2k square 9 over 4 k square. The power is 1 over 2. Now we will simplify it. It becomes a is equal to 2 over 3. We can write 4k square as a 2k whole square whole power 3 over 2 plus 2k square 2k square whole power 1 over 2. This is the upper limit. Minus lower limit is minus 2 over 3 3 over 2k square whole power 3 over 2 plus 2k square 3 over 2k square whole power 1 over 2. Now further simplifying, cancellation 3 over 2 and 2. Also this cancel out or cancel out. The remaining are Now we will simplify it. A will be 2 over 3 8k cube plus 4k cube. This is a simplifying upper limits values minus 2 over 3 27 over 8 k cube plus 3 k cube. A will be 28 k cube over 3 minus 9 over 4 k cube plus 3 k cube. So finally it will be 28 over 3 k cube minus 21 over 4 k cube. By LCM we can write it as 112 k cube minus 63 k cube. LCM of 3 and 4 is 12. Over 12, finally we get area will be 49 over 12 k cube. This is the area of the shaded region in terms of k.